The topic we are going to cover in this slide is work, energy, and power. And this waterfall shown in the picture is shown for a purpose because it has energy in it. It can do work by using this energy and can produce power with it. So there is a huge amount of energy in it. Work. Starting with work, in daily life, work may be writing an essay or typing on a keyboard, but in physics, work is done only when object moves under the influence of force. For example, this lady is moving the trolley or a pram with a force. So she is doing some work. On in the second picture, the boy is applying a force on the wall, but the wall neither the wall nor the boy himself is moving. So there is no work done by the boy because the distance moved is zero. So work is done only when an object moves under the influence of force. Work done by a constant force on an object is the product of force and distance. Mathematically, work done is equal to force into distance. And one thing to be noted that distance must be in the direction of force, right? So force multiplied by the distance moved by the object in the direction of force. We can derive the units from the formula. Units of force are Newton, units of distance are meter. So the units of work are Newton meter, which are equal to joule. So 1 joule is work done by a force of 1 Newton to move the body 1 meter in the direction of force. So for example, here we have a gentleman holding a bag in his hand. He is applying a force on the bag in upward direction, but he himself is moving towards right. So he is doing no work on the bag. The work done by the person on the bag will be zero because the bag is not moving in the direction of the applied force. So here we have simple example. The boy is pushing the trolley. Calculate the work done by the boy in the blue trouser. Work done is equal to force into the distance in the direction of the force. So 30 Newton was the force and 5 meter is the distance. So 150 joule will be the work done. Okay, do you remember our mother used to say that uh, there is energy in the milk, right? So in the second picture, why the car is not doing any work and the lady have to push or the person is pushing the car because there is no energy in the car, right? So it means that energy is needed to do work, right? Energy, our body needs an energy to do work. Motor cars need energy to do work. Everything needs energy to do work. So energy is the capacity to do work. This is the definition of energy, that it is the capacity to do work. Its units are same as the units of work, that is joule. So what we will discuss about energy will be different forms of energy, law of conservation of energy, sources of energy, environmental issues related to use of energy. So the forms of energy, there are different forms of energy: kinetic energy, potential energy. In potential energy, we have further chemical potential energy, gravitational potential energy, and elastic potential energy. Then we have electrical energy, light, thermal energy, nuclear energy, sound. These are all the forms of energies. Okay, let's start with kinetic energy. The energy of a body due to its motion is called kinetic energy. For example, wind has a kinetic energy, so do the sea waves and a spinning frisbee or a soccer ball. So all of these moving things have energy in them that is called kinetic energy. Then rotational kinetic energy. Rotation is also a type of motion. So the energy stored in a body due to its rotation is called rotational kinetic energy. For example, the energy stored in the flywheel shown in the diagram. Okay, potential energy. Potential energy is the stored energy in a system. This form of energy is due to the state, shape, or position of a system. Right. So chemical potential energy, the energy stored in a substance due to the position of atoms or electrons in a substance. The atomic bonds have stored chemical potential energy, which is released when they are broken and the substance undergoes a chemical reaction. For example, this glucose has a formula of C6H12O6. When this bond is broken, energy is released. Similarly, gasoline has a chemical formula, and a battery has a chemical potential energy in the electrolyte in its electrochemical cells. Then we have gravitational potential energy, the energy stored in a body due to its height or its position is called gravitational potential energy. For example, the person in this roller coaster, when they are at a height, they have a gravitational potential energy. And this water has a gravitational potential energy. With that energy, it runs the turbine. Elastic potential energy is the energy stored in a body due to elastic deformation. This is also called strain energy, energy stored in a body due to elastic deformation. Electrical energy, the energy gained by the flow of excess electrons from one atom to another due to electric charge or voltage difference. When there is a voltage difference, electrons flow from one one point to another. So there is and so energy is gained due to that flow of excess electrons. Electric charge or electric energy. For example, if you rub a balloon, right, and it will get stick with a hand. So there is some charge which flow from the balloon to the hand. So one of the two things become negatively charged, the other thing becomes positive charge, and unlike charge, they attract each other. So that is why the balloon gets stuck with the hand. Then we have thermal energy, the energy stored in our body due to its temperature. Thermal energy is also called the internal energy of the body. For example, internal energy of the wood, or that is in the form of fire, or the internal energy formed due to the rubbing of the hands, and the internal energy of the sun. These are all thermal energies. Nuclear energy is the energy released during nuclear reaction. It can be a fusion or a fission reaction. So the energy released during this reaction is called nuclear energy. We are not going into the detail of fusion or fission reaction. We will study it in the chapter of nuclear physics. So here we have a nuclear reactor in the second picture. Light and sound is also a form of energy. Light is an electromagnetic wave that is visible to eye. Sound is a wave of compression and rarefaction by which sound propagates in an elastic medium such as air. We will study light and sound in detail when the chapter of light and sound will come. Calculation of gravitational potential energy. Force to lift the ball is equal to the weight of the ball, which is equal to mg. The distance moved by the ball is the height h. So the total work done is equal to force into the distance. Force was mg, distance was h. So it becomes mgh, which is the formula for the gravitational potential energy. So in this example, if the mass of the ball is 2 kilogram and the gravitational field strength is 10 meter per second square and the value of h, which is height, is 3 meters, so we can calculate the potential energy, which will be 60 joule. Calculation of kinetic energy. A person throws a ball. Kinetic energy is gained is equal to work done by the ball. So F into D is the work done. We know that when a body moves, the equation is F is equal to ma. Acceleration is equal to gain in speed over time taken, which will be equal to v minus 0 over 2. So from here, the distance is equal to average speed into time taken. Average speed will be equal to v minus 0 over 2 into time taken. So the kinetic energy will become, by this, putting the values in this formula, kinetic energy has the formula of half mv square. Principle of conservation of energy states that energy cannot be created nor destroyed, but it can be converted from one form of energy to another. The total energy of an isolated system remain constant or conserved. For example, here the potential energy is changing into kinetic energy, again into potential energy, again into kinetic, then potential, then kinetic. So this is how the one form of energy is transferring into the other form of energy. So what energy change is taking place here? First is the chemical potential energy of the gasoline is converting into gravitational potential energy, which is converting into kinetic energy, which is converting into gravitational potential energy, which is again converting into kinetic energy. So in this example, the stone on the right slide in the figure slides down a smooth slope. What is its speed when it reaches the bottom of the slope? So the potential energy at the top of the slope of this hill will be equal to the kinetic energy at the bottom. Because of law of conservation of energy, total potential energy will be converted into kinetic energy. So mgh will be equal to half mv square. So first of all, we will calculate the value of mgh. M has the value of 4 kilogram, G has the value of 10 Newton per kilogram, and H has the value of 5 meters. So it will be 200 joule. So this 200 joule will be totally converted into kinetic energy, which is equal to half mv square. Now putting the values of m, we will get the value of v, which will be 10 meter per second. So now it's your turn. Think about it. Which energy change is taking place here? I'll give you a few moments. Okay. Chemical energy due to food is converting into kinetic energy, which is converting into electrical energy, and which is converting into light. In this, gravitational potential energy due to the height of the ball is converting into kinetic energy plus sound, which is again converting into gravitational potential energy, and then again that gravitational potential energy is converting into kinetic energy. That sound energy is the waste energy, lost energy, right? So again in this pendulum, gravitational potential energy plus is converting into kinetic energy plus thermal energy due to air friction. That will be very small, negligible in this case of pendulum. That is again converting into gravitational potential energy at the extreme heights, at the extreme left or at extreme right. The velocity will become zero, and that is why the kinetic energy at extreme left and extreme right is zero. At the middle, the height becomes zero. That is why the gravitational potential energy at the middle is zero. So think about it. which energy change is taking place in this dam. Here it is. Gravitational potential energy of the water is converting into kinetic energy of the turbine blades, which is converting into electrical energy in generator. Wind energy. The energy produced by moving wind is called wind energy. Which energy change is taking place here? The kinetic energy of the wind is converting into kinetic energy of the turbine blades, which is converting into electrical energy in generators. Obviously, there are some losses as well. Now, here we have a nuclear reactor. A thermal reactor also works just like this nuclear reactor. The difference between the two is that this the fuel in the thermal reactor is not, and the nuclear reactor is not the same. In thermal reactors, the fuel can be a gasoline or a coal or some other fossil fuel, but in nuclear reactors, radioactive material is used as a fuel. So, what are the energy changes taking place in this reactor? Nuclear energy in the reactor vessel is converting into thermal kinetic energy of the steam, right? That thermal kinetic energy of the steam, when the steam will be produced, it will move very fast and will run the turbine blades, and that thermal kinetic energy of the steam is converting into kinetic energy of the turbine blades, and that kinetic energy of the turbine blades will then run the generator, and electrical energy is produced in the generator. So this is how a generator works, and a reactor, thermal reactor or a nuclear reactor works. Geothermal energy. There is a natural source of power found below the surface of Earth that has been around for centuries. Underground, far below us, there are pools of water heated by magma or molten rocks. These pools of water make up our geothermal reservoirs, harnessing the power of the Earth's temperature to power, heat, or cool our homes and businesses is the essence of geothermal power. So, what type of energy change is taking place here? The geothermal energy, the heat coming from the geothermal energy is converting into thermal energy of the steam, which is converting into kinetic energy of the turbine blades, which is then converting into electrical energy in generators. Tidal energy. The energy produced by the motion of tides or sea waves is called tidal energy. What type of energy change taking place here? Kinetic energy of the sea waves is converting into kinetic energy of the turbine blades, which is converting into electrical energy in generator. Solar energy. In sun the energy is produced by nuclear fusion reaction. Sun rays when fall on the solar panels, they get charged and produce electricity. So the nuclear fusion energy in sun is converting into thermal energy, which is converting into chemical energy of the panels, and which is converting into electrical energy. So this is how it works. Then the next topic is sources of energy. We have two sources of energy, renewable and non-renewable. Renewable fuels are those which can be used again and again to produce energy. For example, wind energy, hydel energy, solar energy, tidal energy. They can be used again and again. Wood biomass, they cannot be used again and again, but they are in abundance. That is why they are also classified as renewable, because wood and biomass, they are in abundance. Geothermal is also a renewable source of energy. Non-renewable sources of energy are those fuels which take millions and millions of years to grow again and cannot be used again. For example, fossil fuels, they take millions years to grow again, and the nuclear materials which cannot be used again and also very harmful for the mankind. Environmental issues with the non-renewable sources of energy. Thermal power plants can cause pollution in a variety of ways. Fuel burning in power stations put carbon dioxide into the atmosphere. The carbon dioxide traps the sun energy and may be adding to global warming. The sulfur dioxide from coal causes acid rain. This can damage the wildlife and agriculture. Transporting fuel may cause pollution, for example, leaking from an oil tanker. The radioactive waste from a nuclear power plant is highly dangerous. Nuclear accidents are very rare, but when they do occur, radioactive gas and dust can be carried to thousands of miles. The next topic is efficiency. By the principle of conservation of energy, total energy output of an ideal machine is equal to total energy input, which means that total energy is converted into other form of energy if there is no waste. However, in reality, useful energy output is always than the energy input. Some energy is dissipated into friction, other in sound and light. The energy that is lost to the surrounding is called waste energy or lost energy. Total energy input is equal to energy output plus wasted energy. So the efficiency will be only the useful energy output over total energy, and useful energy output is always less than the total input. Sneeko power station is the largest power station in Singapore. Fossil fuel is used to generate electricity. It is estimated that 70% of energy input is lost to the as thermal and sound. So the efficiency of this power plant is only 30%. Power. This man is carrying a huge amount of bricks. Can you or me, can we carry this much of bricks weighing 60 kilogram to a first floor 3 meters from the ground? My answer is yes. Why? I can carry them, but 3 bricks or 4 bricks or maximum 5 6 bricks at a time. So work done by the man is 60, which is the mass, into the g mgh. That is the work done by the man, that is equal to 1800 joule. Work done by a simple person like you and me will also be 1800 joule, right? But we have done that work in much more time as compared to this laborer. He has done the same amount of work in lesser time, and we will do the same amount of work in more time. So power is defined as the work done per unit time, or it can also be said that rate of doing work. So the power of the man will be 1800 over 10. If he is taking 10 minutes, so it will be 1800 over 10. So that will be equal to 180. And the power and your power, my power, or a simple person's power will be 1800 over 100. I am taking 10 times more time than him. So my power will be 18. So the man is 10 times more powerful than us. It's just an assumption. Power is equal to work done over time or energy over time. So the units are joule per second, which are equal to watt. In the example, Ali weighs 450 Newton, runs upstairs, that is the weight mg. If there are total 10 steps and the step of each height is 0.2 meters, the height of the 10 steps will be 2 meter. Calculate the power of the Ali taken in 5, if it takes 5 seconds. So his work done will be force into distance will be mgh or F into D, 450 into 2 meters, that will be 900 joule, divided by the time will give us the power will be 180 watt. So that was the end of the chapter. These are the all topics covered in this chapter. The notes of this chapter are available in the description. You can get the notes from there, and take care. Allah Hafiz.